Alright, here are all the things on tomorrow's quiz. First, determining displacement graphically. Basically, that means taking a velocity time graph and using the area under the curve to find displacement. Okay? Same as on last quiz, finding the area under the curve to find displacement. Yep. Then, next up is relating kinematic graphs. So you need to be able to take a position graph and make a velocity graph, or take a velocity graph and make an acceleration graph. So just like we spent that one day where you had position graphs, made velocity graphs, made acceleration graphs, you've got to be able to do that. That's relating kinematics graphs. So we've talked about determining displacement graphically, relating kinematics graphs. Next up, average speed, average acceleration. No, sorry, average speed, average velocity, constant motion. Let's talk about that one because there are a few parts that might trip you up. So I might ask you a question that says something like, given this graph, find the instantaneous acceleration at 12 seconds. Alright, and then I can see a lot of people freaking out. Whoa, I don't know what to do. Well, we haven't talked about this much because it's pretty simple. So if I'm asked to find the instantaneous velocity at 12 seconds, first, instantaneous acceleration at 12 seconds. First I'll find 12 seconds, and I'll just draw a little dotted line to show that I'm looking at the 12 seconds part. So I'm looking at the graph there. Acceleration, remember, is just the slope of velocity time. So the instantaneous acceleration is whatever the slope is at 12 seconds. And it's pretty clear on the graph that the slope at 12 seconds is the same as the slope from 10 to 15 seconds, because the slope of that part of the graph is constant. And it should be pretty obvious to you that there are actually three slopes on this graph, one for section A, a different one for section B, and a final third slope for section C. Since 12 seconds falls in that section B, we're looking at the slope for section B. So let's find it. Slope for section B, which is, remember, the instantaneous acceleration at 12 seconds. Alright. So I can see pretty clearly from the graph that the change in y during that part goes from 2 meters per second up to 6 meters per second, which is a change in y of 4 seconds. And then the change in x goes from 10 to 15 seconds, so that's 5 seconds. That 4 has the wrong units, so that was 4 meters per second because my y-axis is in meters per second. Okay, so now I divide and I get 0.8 meters per second squared. Notice all I did was find a slope for one part of the graph. That's the instantaneous acceleration on a velocity time graph. If you were given a position time graph and asked to find the instantaneous velocity, you'd be finding the slope on the position time graph. So let's do one like that. Okay, this is a position time graph. Let's say, well, first it needs some times. So I'm just going to draw these real quick. Let's call this 1 second, and 2, and 3, and 4, and 5, and 6, and 7, and we'll know those are all in seconds. Let's say I asked you to find the instantaneous acceleration. Nope, I keep doing that. Let's say I asked you to find the instantaneous velocity at 4 seconds. Alright, to find the instantaneous velocity at 4 seconds, I do a little dotted line so I can see where I'm focused on. Okay, so there's a curve there. I think I don't know how to find the slope of a curve. Okay, but you can estimate this one part of the curve right here. That's nearly a diagonal line. So what you do is find the slope for this diagonal line. And so slope is just rise over run. And we have up at the top whatever b is. Oh, I'm going to have to assign numbers to the x-axis. This is just a bad graph I picked. Alright, let's all remember these are in meters. 1, 2, 3, 4. Okay, those are all in meters. Okay, so back to what I was doing. Slope. This section that I've drawn here goes from B down to here. So that's about 4 meters down to 1 meter. So my rise is 3 meters. And my run, so B starts about at 3.5 it looks like. And then that little section ends at 5.5. So 5.5 minus 3.5 is 2 seconds. My instantaneous velocity then is about 1.5 meters per second. So instantaneous velocity is finding the slope of one section of the graph. And just a reminder, that was the slope or the instantaneous velocity at 4 seconds. Okay? Okay, to summarize, instantaneous velocity or instantaneous acceleration is the slope of one segment of a position time graph, that would be instantaneous velocity, or velocity time graph, that would be instantaneous acceleration. If that is confusing to you, there is an instantaneous section in your textbook that I'll refer you to. Let me find it real quick. Section 2.3, starting on page 24, talks about instantaneous velocity and how you find it. They got some good bullet point parts, so you can take a look at that. And then there's instantaneous acceleration over on page 27. It's defined, and they give you a couple of examples. So if those are confusing to you, take a look at those pages. Okay. So we've covered instantaneous velocity and acceleration. The other part of average speed, average velocity that I want you to remember is that average speed, so average S, just using that for shorthand, not necessarily a symbol you should recognize. So average speed, remember, is total distance over total time. No directions involved, total distance, add it all up, total time. Average velocity, so average velocity is displacement over time. And for the few people who memorized that definition, I'm going to separate these real fast. It's displacement over elapsed time. But if you just remember, find the displacement, divide by the time it took. So speed, you just add up all the distances no matter the direction. Average velocity, you find the displacement over time. You do have to remember those definitions. There's not going to be a formula sheet on the multiple choice part. So total distance, total time, average speed, displacement over elapsed time, velocity, average velocity. Okay, we're getting near the end. I'm looking at the quiz, seeing if there's anything else you need to know. You're asked to calculate the acceleration of a couple things. I don't think there's an average acceleration question. Nope. So let's think about the equations you'll need to know for acceleration. Okay, you don't get to have the formula sheet with you during the multiple choice part of this quiz. So flip with me to page 46 and let's look at a couple important equations. So one that came up a lot in class and a lot in the classwork is final velocity equals initial velocity plus acceleration times time. Okay? So you should have that one pretty much down cold. And also, a lot of people liked to remember the solution for acceleration here. But if you memorize this right here, you can then solve for acceleration. So the one that became popular in class was solving this for acceleration, which was this. So a lot of people ended up just remembering this. But this, right here in green, comes out of final velocity equals initial velocity plus acceleration times time. So I would memorize that black equation, and you can find the green equation from it if you need to. Alright, another equation that you might need is one of my favorites. X equals x naught plus v naught t plus 1/2 at squared. I do just love that equation. It is so very beautiful. Right, and then the other one would be v squared equals v naught squared plus 2 times acceleration times delta x. Let me rank these in order of importance for you to memorize. So this is a helpful hint from Mr. Melvin. How nice of him. This equation right here, v equals v naught plus at, most important. Get that one down. You can do most of the problems on the quiz with that. The next most important one would be this equation here. X equals x naught plus v naught t plus 1/2 at squared. And then the third most, v squared equals v naught squared plus 2a delta x. Really that top one, you could probably figure out almost all of them from. So if you memorize nothing else, get that top one down. Alright, I'm going to scan back through the quiz, see if there's anything big, point out a couple things. Alright, you got to be able to find displacement graphically, area under a curve. You need to be able to find instantaneous velocity, instantaneous acceleration. Remember, that's just a slope of one part of the graph. So estimating slopes. You need to be able to read position, velocity, and acceleration graphs. You need to be able to make a velocity graph from a position graph and an acceleration graph from a velocity graph. A couple of those. Instantaneous acceleration, average speed, average velocity, find acceleration, find speed given an acceleration. Alright, so I pretty much, if you want to rewind for the last 30 seconds, just read the questions to you. Alright, so no excuse for not being prepared because I just read the questions to you pretty much. That's all. Be ready. See you tomorrow. Good luck.